Hello class, this is Miss Chen from Future Academy. Today I'm going to talk about how do we solve the questions regarding find the range of k for a particular condition. For example, in this question, find the range of k for all real values of x such that 2x squared plus k times 4x minus 3x squared plus 2 is either always positive in part A or 2. In part 2 is never positive. So first of all, let's talk about the concept. Because if we rearrange the terms in the question, what we are going to get will be something like this. So we have to rearrange the terms in descending power of x. Okay, let me do the simplification first. Okay, so I will have 2 minus 3k x squared plus 4kx plus 2. Right, this is my expression. So imagine we are going to draw the graph of it. How does it look like? If it's always positive, the graph should look like this, right? So the entire graph should be above the x-axis. This is what we mean by always positive. So there are actually two conditions. First of all, the a in the general form of ax squared plus bx plus c equals to 0, the coefficient of x squared, linear term, and the constant term, all of them there's a condition. First condition is a must be positive. In this example is 2 minus 3k should be greater than 0. And the second condition is discriminant should be less than 0. So that there is no intersection point between the graph and the x-axis. Okay. How do we get the discriminant? We shall use a formula b squared minus 4ac. What is the b here? Is 4k. Okay, so 4k whole thing squared. Please remember the whole thing squared, because if you have 4k squared, it is not correct. Okay, times 4 times a, which is 2 minus 3k, times c, which is 2. Okay, this should be less than 0. Let's expand it. We will have 24k less than 0. In order to simplify, I shall divide it by 8 throughout the equation, because do you see throughout the inequality, do you see 16, negative 16 and the positive 24? Both of them are all of them are multiple of 8. So what am I going to do is 2k squared plus 3k minus 2 less than 0. How do I solve this inequality? I actually need to sketch the graph. Factorize, find the two solutions first. So the graph for this part will look like that. Negative 2 and half at the two roots, right? So what happens is, if I'm looking for less than 0, I'm actually focused on this part. Negative part below the x-axis, this part, right? So what do? I shall actually look at the region between the two roots. So it should be between the two solutions. K should be greater than negative 2 and less than half. Is that the final answer? Not really. We still need to look at the other condition. Solve 2 2 minus 3k greater than 0, what I can do is I'm going to move the 2 to the other side and it becomes negative 2. Then I'll divide both sides of the equation by 3. Okay. This is what I get. But I may ask you to think about what is the sign in between. Both sides of the inequality divided by negative 3, right? So what's the sign in between? The sign shall reverse because it's a negative number. Because divided by, let me redo it. Okay. We divided by negative 3 on both sides, so we shall reverse the sign. Then we look at what is the common set. We shall actually draw another line again. So we have negative 2 half and less than 2 over 3. What is the overlapping area? Will be this part, right? So the final answer is therefore k should be between negative 2 and half. Bear in mind the condition is and, so both inequalities shall be satisfied. That's why we are looking for the overlapping area. Okay. Now let's look at the second part. Part 2. We are going to do second part based on understanding if this graph never positive, it should look like this. This is 0. Okay. So basically I will say the A should be less than 0 and discriminant is less or equals to 0. Why do I say less or equals to 0? Because there will be two conditions. First case is d equals to 0. So it's actually 0 touching the x-axis at one point. The other case is d is less than 0. So the graph may look like this. We shall include both cases, because never positive means could be 0 or negative or just purely negative. Okay? For those students have been with us for some time, you know that all this work done in pink color pen is not required in your assignment or assessment. It's just for explanation purpose. So now we can make use of what we get from part A. For A is 2 minus 3k, which is less than 0. And the other condition is discriminant, which is 2k squared plus 3k. Minus 2 less or equals to 0. So solve the first inequality, we will get k should be greater than 2 over 3. And solve the second inequality, we still will do the factorization approach. Let me spend a little bit more time to talk about how do we solve this. First of all, we shall factorize the expression, and then we will have the two solutions for the expression equals to 0, which is at point negative 2 and half, right? So less or equals to 0 will be the entire thing here. Compared to just now the case, we shall exclude the 2 points. Okay, this inequality, because it can be equal, so these 2 points, the boundary points, will be inclusive in your solution set. So what we can continue is -2 and half, both inclusive in the solution set. We have found the inequality for the range of k for both cases. Then subsequently what we need to do is we have to draw the number line again. We have -2 and a half and the 2/3 greater than 2/3 and between -2 and a half inclusive. This is what we can do. Okay, so therefore, there's no intersection area, right? This set and this set, there's no overlapping area, so we can say no solution. Okay, that's the answer. No solution sometimes is also an answer. So now let's look at the question one more time. This is quite an interesting question. First of all, we want to find the range of k to make the expression either positive or negative. We shall think about express it in the general form of a quadratic expression, which is ax squared plus bx plus c, right? So your a is 2 minus 3k, your b will be 4k, and c is 2. When you substitute a, b, c into the expression, you will get 4k whole thing squared minus 4 times 2 minus 3k times 2. And because we don't want to see any intersection point, in order to get always positive. Always positive means the entire graph is above the x-axis. There is no intersection point, so we focus on the less than 0 for the discriminant. Because no intersection point, discriminant should be less than 0. And then we'll solve this inequality. We can use the graph approach, and we'll have the answer -2 less than k and less than half. Don't forget the other condition is a must be a positive value such that this entire graph is above the x-axis. So we'll solve the other inequality and get the answer k less than 2/3. So we are looking for the intersection area because we have this part, okay, for the the second inequality, and the other solution set is the line below, and we have the intersection area, which is in between the two, -2 and a half. That is our final answer. For part 2, because it's never positive, it actually includes two cases. First case is touching x-axis. The second one is never touch x-axis. So could be equals to 0 for the discriminant or discriminant less than 0. We can combine them into one inequality, which is discriminant less or equals to 0. Subsequently, we solve the equation and we realize the intersection area of the two inequality is nothing because you cannot find a common set if after solve both inequality. So the final answer is there's no solution for the k. Okay, so this is an interesting question, and it is under A math, under the solutions for quadratic equation, nature of roots. Okay, this is under nature of roots. Okay, thank you for your attention. Bye bye.